then you will be getting the question wrong. So let us try to answer this question. In this question, we are given a quadratic equation p square minus 9 into x square plus p square minus 2p minus 3 into x plus p is equal to 0. We are told that there are two roots for this equation and both of them are less than 0. We are required to calculate all the values of p which are less than or equal to 10 and which are integers for which this condition is satisfied. So the first thing that you should notice is that because this equation has two roots, the discriminant will be positive. If you are given a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the discriminant is b square minus 4ac. So this has to be greater than 0. Secondly, we are told that this has two roots. So that would imply that a is not equal to 0, or the coefficient of x square is not equal to 0. If the coefficient of x square is equal to 0, then the equation will have only one root. The next thing you should notice is that because both the roots are less than 0, so they are negative, this would imply that the sum of the roots is negative and the product of the roots is positive. What does that mean? If you are given a quadratic equation, the sum of the roots is equal to minus b by a, and the product of the roots is equal to c by a. We are told that both the roots are negative, so this would imply that the product of the roots will be positive and sum of the roots will be negative. Again, if you have two roots, if both are positive, if both the roots are positive, then the sum of the roots will be positive and product will be positive, because the sum of two positive numbers will be positive and the product of two positive numbers will be positive. If both the roots are negative, which is what we are required to find out in this particular case, that is the sum of two negative numbers will be negative and the product of two negative numbers will be positive. If one of the roots is positive and if one of the roots is negative, the sum can be either positive or negative, but the product will definitely be negative. This is the theory which we will use to solve this question. So in this question, the first thing we have to notice is that p square minus 9 cannot be equal to 0. So p square minus 9 is not equal to 0. So p is not equal to minus 3 or plus 3. The next thing is to figure out that the discriminant is greater than 0. The next thing to notice is that the sum of the roots is negative and the product of the roots is positive. What is the sum of the roots? The sum of the roots is minus of p square minus 2p minus 3 divided by p square minus 9. The sum of the roots has to be negative, so this is less than 0. Or if you multiply the entire equation with minus 1, this will be equal to p square minus 2p minus 3 divided by p square minus 9 has to be greater than 0. And the product of the roots has to be positive. What is the product of the roots? That is p divided by p square minus 9 has to be greater than 0. The first inequality, the numerator is p square minus 2p minus 3. That can be factorized to equal p minus 3 into p plus 1 divided by p square minus 9 is p minus 3 into p plus 3. This has to be greater than 0. We can cancel p minus 3 in the numerator and denominator, or if you multiply the numerator and denominator with p plus 3 whole square, this inequality will become equal to p plus 1 into p plus 3 has to be greater than 0. Or the value of p should lie between minus infinity to minus 3 union minus 1 to infinity. If you're looking only for integers, just to get a better sense, that will be minus infinity to dot 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 minus 6 minus 5 minus 4 union 0 1 2 dot 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 till infinity. We know that all of them have to be less than 10, so we'll come to that later. The second inequality which says that p divided by p square minus 9 is greater than 0. If you multiply the numerator and denominator with p square minus 9 whole square, this becomes equal to p into p square minus 9 has to be greater than 0, or p plus 3 into p minus 3 has to be greater than 0. What are the three roots of this cubic equation? The three roots are minus 3, 0 and 3. So if P is greater than 3, all the 3 terms will be positive. So this equation is satisfied. So the roots will be, P will be, or if you are drawing a timeline like this for this cubic equation, this is minus 3, this is 0 and this is 3. If P is greater than 3, all the 3 terms P plus 3, P and P minus 3 will be positive, so the product will be positive. If P lies between 0 and 3, then P will be positive, P plus 3 will be positive, but P minus 3 will be negative. So the product will be the product of 2 positive numbers and 1 negative number, so this will be negative. If P lies between minus 3 and 0, 2 terms will be negative, so their product will be positive, and the third term, which is P plus 3, will be positive. So again the product will be positive. And finally, if P is less than minus 3, all the 3 terms will be negative, so this also will be negative. So the equation is satisfied for the values of P, which include minus 1, minus 2, that is this case, union 4, 5, 6, till infinity. We want both these conditions to be satisfied. We want the product to be greater than 0 and we want the sum to be less than 0. The overlap of these two intervals is if the value of P is between 4 to infinity, but we want P to be less than or equal to 10. So the values of P that P can take are 4, 5, 6, 7, 8, 9 and 10. But we have one important condition which we did not check as of now, which is that the discriminant has to be greater than 0. Only then will a cubic equation or a quadratic equation will have 2 real roots. Otherwise some of the roots can be imaginary. What is the value of t, that is the discriminant, is t square minus 2p minus 3 whole square, that is p minus 3 whole square into p plus 1 whole square. This is simply p square minus 2p minus 3 whole square. P square minus 2p minus 3 is equal to p minus 3 to p plus 1. So this whole square has to be greater than 4 times p square minus 9. So that is p minus 3 into p plus 3 into p. The values of p that we are concerned about are only 4 to 10. And for all of them, the value of p minus 3 is greater than 0. So we can cancel 1p minus 3 and 1p minus 3. The left hand side will become equal to p minus 3 into p plus 1 whole square. This is greater than 4 into p square plus 12p. P minus 3 into p plus 1 whole square will be p minus 3 into p square plus 2p plus 1. If you are expanding this, this will be equal to p cube minus 3p square plus 2p square minus 6p plus p minus 3 has to be greater than 4p square plus 12p. Or if you are simplifying this, this is going to equal p cube has to be greater than, if you are bringing all the remaining terms to the right hand side, 4p square minus 2p square plus 3p square will be 5p square plus 12p plus 6p, 18p minus p will be 17p plus 3. This equation is not satisfied when p is equal to 4, because pq will be 64 and that will be definitely less than 5 into p square. That inequality is not satisfied when p is equal to 5, because again you know that pq will be equal to 5p square and the remaining terms will be positive. Will the equation be satisfied when p is equal to 6? P cube is equal to 216. And 5p square is 5 into 36, which is equal to 180, plus 17 into 6 is greater than 100. So again this equation is not satisfied. Will this inequality be satisfied when p is equal to 7? P cube will be equal to 343. And 5p square will be 5 into 49, which is equal to 245. Plus 17p is 17 into 7, that is equal to 119. So again this equation is not satisfied when p is equal to 7. Will this equation be satisfied when p is equal to 8? P cube will be equal to 512. 5p square will be 5 into 64, which is 320. 17p will be 17 into 8. 17 into 8 is equal to 80 plus 56, which is 136 plus 3. Now you can see that this is approximately 460. I think this is 459. So this equation is satisfied when p is equal to 8. you know that you can check for p is equal to 9 and p is equal to 10, but clearly the rate of increase of the left hand side, which involves a cubic term, will be higher as the value of p increases. You can manually check it for p is equal to 9 and p is equal to 10, but you know that the left hand side is increasing much faster as compared to the right hand side, so the equation will be satisfied when p is equal to 8, 9 or 10. So the sum of all the values of p for which this cubic equation is satisfied, or this quadratic equation will have two roots which are both negative, is 8 plus 9 plus 10, which is equal to 27. Again, as mentioned at the start of the question, this kind of a question will require a lot of conceptual understanding with respect to what are the conditions that are required for the quadratic equation to have two roots, what are the conditions required for both the roots to be positive or both the roots to be negative. So first, getting the understanding is important. Even if you have your understanding correct, actually making all these cases and trying to narrow down the values of p to be just 8, 9 and 10 requires a lot of time and effort. And even if you make a small mistake, for example, if you have left out just reading the question correctly, instead of looking at the fact that p can be less than or equal to 10, if you assume that p is just less than 10, then you would ignore the last term, which is 10, and you will get the answer wrong. So these kind of questions in general should be left alone in the examination because they require a lot of time, which can be better spent in answering other questions.
क्वेश्चन वापस रिकॉर्ड किया